Hello and welcome to today's webinar featuring the all-new Trident. My name is Jim Heenan. My role at Axes is Sales Manager for Routers and Knife Cutting Solutions in North America. Just want to give you a quick rundown of today's agenda. We're first going to begin this live webinar by talking a little bit about the new Trident. Then we're going to proceed with a live demonstration on our new machine. We're going to be cutting a variety of different materials. So at any time during the presentation, please feel free to ask questions. You may use the chat box at the bottom of the software application or just send us an email to openhouse@axes.com. At the end of the presentation, we will be answering the questions. We're going to do the best we can to answer as many as possible. If any question is left unanswered, we will send you an email following up. Again, thank you for your time, and let's get the product demonstration started. Okay, I'd like to briefly touch on Axes Automation Group, or AAG, as a company. AAG is a global leader in tailored cutting solutions. What this means is that our products are highly configurable to ensure we fit your applications, materials, and needs. Axes Automation Group represents three brands: Axes CNC Routers and Knife Systems, WardJet, our water jet manufacturing division, and CNC Shop, the aftermarket entity providing online consumable and part sales. All of our router and knife systems are manufactured in Toronto, Ontario. Our water jet cutting systems are manufactured in Talmadge, Ohio. Okay, so today is all about the new Trident. The Trident is the most versatile router hybrid in the world because it combines industrial routing performance with high-speed knife cutting. All of this is achieved in a compact footprint. The range of materials processed is almost limitless. Routing and knife cutting capacity of up to 4 inches in material thickness really sets the Trident apart from the competition. So I'm going to show a quick video here. What we've done with the all-new Trident is we've built off of the success of our router automatic tool change system, as you can see here, changing tools with the spindle. We've created a new tool changer that'll work with tangential knife devices. So the tangential knife tool changer is a powerful addition to the Trident, which directly improves workflow for users processing a wide range of materials, such as corrugated cardboard, cardstock, foam core, or rubber for gaskets. So as you can see in the video, the tangential knife tool changer introduces automation to the knife cutting process. What we've done is we've allowed storage of up to 4 tangential knife cutting devices. By doing this, operator interaction is reduced in jobs requiring multiple knife cartridges. Not only does this reduce cycle times and improve throughput, but it makes the programming of jobs much easier. So another feature on the all-new Trident is what we've done is we've built off of the success of the existing Trident's tooltip sensor for spindles. And we've introduced a new method of automatically calculating the length of knife blades. Our new laser-based sensor will calculate the length of your oscillating or tangential knife tools. It'll also determine the angle of the blade and automatically apply a correction. The automation of this process has greatly increased the accuracy of calibration and depth control. So not only does the knife calibrator provide higher accuracy and is a much quicker process, it's also safer. It's a hands-free process that gives you the added benefit of prolonging the life of your knife blades and consumables. The accuracy of the angle is within 1 degree, whereas manual calibration can be up to 4 degrees off from the center position. Another key feature on the all-new Trident is our new electric oscillating knife. The electric oscillating knife is a true game changer as it combines higher speed cutting and quieter operation. The electric oscillating knife expands the variety of materials users can cut and reduces overall cut time significantly. This is achieved through faster oscillation, which translates directly to faster cut speeds. Faster cut speeds means more parts per hour. Some examples include cutting 13mm rubber in 1 pass versus 2, and cutting 13mm Falcon board, which you just saw in the video, at 550 inches per minute versus 300 inches per minute. Okay, so now we're going to shift things over to the live product demonstration. Noel Archie is at our main facility in Burlington, Ontario. Noel is going to be walking us through the applications and demonstrating the powerful combination of industrial routing and high-speed knife cutting of the all-new Trident.
Thanks, Jim. I'm just going to do a quick review of the machine configuration. On this particular platform, we try to make a multi-dimensional system that allows you to cut a variety of materials without having to switch tools or options. We have 2 knives and a spindle. We start off with the tang knife. The tangential knife is hooked up to our linear 4-position ATC, which allows you to have 4 tools that will be automatically changed depending on what you're cutting. But it also has the capacity to put in a tool manually if you needed to. Next to the tangential knife is our new electric knife. The nice thing about the electric knife, it gives you the ability to cut materials a lot more rigid and a lot quicker than the previous knife we had. We also now have our 3rd cutting head, which is our 10 horsepower HSD spindle. That gives me the ability to cut whether it be aluminum, plywoods. A really diverse amount of material can be cut in this platform. This tool spindle is connected to our rotary tool changer. This particular tool changer has 10 positions. We also sell 7, 10, 14, and 21 position tool changers. So within this platform, I have the ability to cut any number of materials from falcon board to aluminums, acrylics, plywoods. There's really nothing that I cannot process on this particular system without having to spend time changing options because all my tools are live. So the first job we're going to run is going to be using our last option here, which is our vision system. The vision system allows you to find jobs that require registration. And what I mean by that is, I've printed this job and I've placed it on the table. Now that it's on the bed, I don't know where it is in space. So the vision system will now go out, find the registration marks, determine the position of the job on the bed, and then we'll be able to cut it out. Okay, so that's what we're going to do next. So we're just going to get this job running. So the first thing we'll do is find the first registration mark, I think in the far left-hand corner, and then we'll move around the system. So I'll get out of the way so you can see what you came to see, which is the table running. So what you just heard was the system getting ready to go, the vacuum automatically turning on, and here we go. We're going to find the first registration mark. That's registration mark number 1. The camera is aligning to it. Perfect. It goes to the second location. It looks for the second dot. As you can see, the movement is where the camera is basically looking for the registration mark. It's found the 3rd dot. And now it goes to the last one. So the nice thing about this system, I can use that vision system with my electric knife, which I'm using right now, or with my tangential knife, or even my spindle. So there is no reason why I couldn't be cutting this job out on a sheet of coroplast or thin gauge aluminum or even 1/2-inch aluminum. There's no restrictions because the system is so diverse. So we're just coming up to the end of this job, and I'll take it out so you can see the quality of the cut after it's finished. Once the job ends, the machine will actually move to the back for a parking location so you can easily get access to the job. I'll take it out now so you can have a good look at what we've done. Again, when you're cutting with a knife, you're not actually removing material. That's why it's such a tight fit. So that's the item that we just finished cutting. Again, nice good edge quality, nice consistent position of the job. Again, this is falcon board. So the next material we're going to cut will be a similar material, different core to it. We want to show another aspect of the machine. We're going to look at, again, running 2 different knives. We're going to be running the 45-degree blade in the tangential knife and the electric oscillating knife again. Okay, I'm going to get that job running now. So one of the things you'll see happen now, we'll basically go ahead, and once we run the job, it requires a tool change. So the tangential knife will go over and automatically pick up the tool that it requires to run the 45-degree cut. Okay, the job starts. It realizes that it doesn't have the correct knife loaded or tool loaded. It will go over pick up the tool. Now that the tool has been inserted, it will go ahead and run the first part of the job. Okay. So if you have any jobs where you're cutting thicker material, where you want to do folding, and you can't use, say, a spindle to do a V-route or an angle tool in the spindle. This is where the 45-degree blade comes in handy. Just a quick and easy job we're running here just to show you the capacity of this particular option. So it's basically cutting 2 V cuts on each side to create that fold that we require. Okay. Almost finished the process. Now we switch to the oscillating knife, which will cut the piece out. Again, very little, if any, operator interaction. Last cut. Again, the beauty of the parking spot, it moves out of the way so you can see or get to the job you've just cut out. Nice clean cuts with a 45-degree blade. All the pieces pop out nice and cleanly. That's your finished product. Okay. So I can use this on, again, we use right now Falcon board, we can use foam board, a variety of materials that you're cutting. If you're making some kind of a packaging material using a very thick cardboard or corrugated cardboard, you can use the same technique. Okay, we'll move on to our next job we're going to be cutting. We'll be using the spindle next. So we'll just cut out for a second while we get that prepped and ready to go. Okay, we're going to start running our next job. We'll be running an acrylic sheet. So we're running the spindle this time. Again, we went straight from using a knife to using the spindle. No tool changing manually required in this particular process. So when we're cutting the acrylic, one of the big enemies of routing or cutting is heat. And the way we've dealt with that heat is with the cold air gun. The cold air gun takes regular compressed air and chills it down. So it pumps that compressed air into the dust collection boot, and that allows that air in there to be cool, cooling the tool and cooling the material where the tool interacts with it. It also causes the chips to move around. That way you get a better chip evacuation. That's also very important when cutting acrylic, because if I don't get proper chip evacuation, I will get heat sitting in my cut, thus causing the rewelding to occur. If I get the rewelding, I will not get that nice clean edge that I'm trying to develop when cutting this particular job. Okay. So now it's basically going on, we switch tools. We've done our basic engrave of the panel, or the first pass of the panel, which is our rough cut. Now we're doing our finish pass. We'll tend to do a slower feed rate on the finish pass, again trying to get that nice polished edge. Our objective here is to basically get a part right off the table that has a nice clean finish to it, having to do very minimal any secondary work after we've cut it. So the cold air gun is the first thing we want to look at when we're running a particular job like this. And again, our next important aspect of running this job is the chip collection. I want to be sure I get really good chip collection. I need to get those chips out of that cut. Again, the chips will pull away the heat. The cold air gun will also help reduce the heat because it's chilling the boot. And because I've done that, I will, again, minimize the likelihood of getting any rewelds. For this particular job, we're using a 1/4 inch O flute. Job is finished. Let's go take a look at that finished part and see what it looks like. Okay, as you can see, the pins came back up automatically. These are my alignment pins. This allows me to basically go from one sheet to the next by just, pushing up against the pins. I'm going to pull the part out. As you can see, very little, if any, dust on the table. I'm going to pull this off here. This is my finished plastic on this. Again, this had a mask on it, okay? Because it had a mask, I'm just going to pull the machine to the front for a second so we can get a better look at this. The particular dust collection boot or foot that we use on this system is set up so it can ride right above the material, or basically physically touching it. That's important. If by chance I was running a material that didn't have a masking on it, it was fully exposed, so my acrylic came unmasked, using this particular foot puts me at in the right place. I can now set that foot up so that the bottom of it just sits slightly above the material, still gives me a dust collection I want, but it's not scratching the surface. Okay. So again, this is my finished product. A nice clean edge. Again, it simply fits into the piece I had cut earlier. So again, what we're trying to establish here is the ability to go from cutting with a knife to cutting with a spindle. Getting a beautiful edge quality cut with the knife, getting an amazing edge quality cut with the spindle. Okay. Now we'll move on to the next phase of our presentation. If anyone has any questions, we'll basically go through and answer those questions. If we don't get to all the questions today, we'll make sure and get those answers out to you at a later date.
Great. Okay, great. Thank you, everyone. I'm just going to run through some of the questions that we have people that have posted here. Again, one of the questions everyone's been asking is, will the recording be available? Yes, it will be available. We will compile it after the session and make it available to everyone. Another question we have here, how can I buy one? When you're looking to buy a machine, you can basically lean on one of our sales people. Jimmy, you want to grab that question in terms of where and when we can buy a machine?
Sure. If you just contact us, we'll get you in touch with the appropriate office, the appropriate salesperson. We do have 10 offices in North America, depending on where you're located. We do have demo machines available. We've also certainly can build new ones. Our lead time right now on standard machines is right about 7 weeks, and then on tailored machines, it's closer to 9 or 10.
Okay, thanks, Jim. Can the camera be used to cut non-registered? Can the camera be used to register non-printed material? Yes, it can be. One of the application webinars we will be running in the not too distant future will actually go through that process where I can use the registration process for something that doesn't have prints on it, for cutting, machining something that has double-side machining. So look out for that information regarding our upcoming application webinars in the not too distant future. How does the machine know which tool is needed to do the job? Well, basically that happens in the software. So we're running VCAR for this particular job, but you can use en route to any variety of CAM software out there that has the right tools for our machine. When you go into your CAM software, you would decide, depending on the process, which tool you would use, and then you would sequence the process accordingly. So I'll do my internal work before I do my external work. The tooling number that I have in my file will match up to the tooling number I have at my machine. Okay. If we had to simply cut a 4x8 sheet into 18 by 24 signs, do we need targets? You would only need targets if there's something printed on it. So if I have just a plain sheet of material I'm cutting into sizes, I will not need a registration targets or AVS system. But once I print something on it, I need to determine where it's located on the bed. At that point, I will need to add the camera. Again, on our machine, that's something that can be retrofitted if you require that process. Can the electric knife have an ATC too? Currently, the electric knife does not have an ATC option. Again, engineering is always working on new options over time. Second part of that question, we cut a lot of foam and we always have an issue with the knife flexing, giving us a crooked cut. Again, that to me, like tooling like anything else, whether it be a spindle or a knife, depending on the tool you're using in there. I will look at probably using a double-edged blade that tends to be a lot stiffer, so the ribs right down the middle. If you have questions or concerns about doing that particular process, please reach out to us, and someone in application, whether it be myself or one of the other guys in the group, will contact you and help you work through that particular issue. Another question is, what RIP software did you use? Again, you can use a variety of packages out there for doing this process. You can go from Illustrator right into, say, the VCAF software, or you can use Onyx or Caldera. They all work well within the system. Okay. Just going through all the questions here. Hi, what is the best software to use to register your print and cut files? Again, you can draw in Illustrator, right? And you can go right from Illustrator and create your print that way, and then take and send the print file to your flatbed printer, send the vector and the registration marks to your CAM engine, or you can go to something like Onyx, where you can do a lot more work, and that can just get integrated right out to the router, depending on how you have it configured. Can the tooltip sensor be fitted into the pneumatic oscillating knife as a retrofit? That's something we're working on. That's a package that we have available. And again, any of those questions regarding retrofits to existing systems, please reach out to someone in aftermarket or in the sales group, and we'll give you the correct information. What was the tools you used for cutting the acrylic? We use, again, I mentioned earlier, we used an O-flute tool, and that O-flute tool can be purchased in CNC shop. Currently, we're running a 10% discount for all tools in CNC shop, and that runs till, one second, just double check, the 13th of June. There should be a handout in the meeting that basically gives you the coupon code for that 10% discount. So if you want to grab it and so you can use it. If for any reason you're unable to get that coupon out of the handout section of the webinar, please, again, send an email to us and we'll make sure you get it out to you. What is the more effective, vacuum pump or motor? Or plastic sheets, 10 millimeter thick honeycomb, and we are not really flat, need to pull them flat. Again, vacuum typically, a lot of times it depends on square footage. If you're having issues, if material tends to be twisted and it's a flexible material, you'll typically have a lot more issues holding it down. One of the things we do to offset sometimes, especially anything that's possibly flexible, is our pressure foot option. So on the machine, we ran the 5-wire, which runs slightly above the material. The pressure foot applies some downward force to material while you're cutting. Again, we have a variety of options to use, but if your material is very twisted, you have to take into account that the vacuum will hold it down. You may have some release as you start cutting, but a lot of it is about setup, sequencing the job, start points. If there's a particular job you're trying to run and you have, again, concerns or questions, please reach out to someone in applications and we'll be able to help you with that question, with that concern. What have we got here for time? Got a couple more minutes. What size is it and the price range? So Jim, you want to grab that question? Someone wants to know what in terms of the size of that machine and price range relative to that size.
Sure. So the machine in the demo was our 4010 model, which is actually 60 by 120 workable area. Depending on where you are in the world, we can get you a quotation on it. We're dealing with multiple markets, so we'd like to have a salesperson contact you directly to get you pricing for your region.
Thanks, Jim. Okay. Just going through
Hey,
a
Noel.
bunch of questions. Yes.
So just to follow up, I'm looking at the questions here as well. I think it was a follow up on the one about cutting the 18 by 24. He was asking if you could do, if you needed the vision, if you just wanted to cut the parts. What you could do is if you have it printed and it's centered on that on the sheet, you can use the pop-up pins to locate. So your 0, 0 point's always going to be the same. So theoretically, you wouldn't need the vision to do that if you've got like a bleed line. If you're just looking to cut out, you know, he mentions here that the registration wouldn't have to be perfect.
Okay. Perfect. Someone else mentioned. Okay. Yeah. So it all depends on your flatbed printer. Your flatbed, again, most flatbed printers not print really accurately. So if you can print something that's very accurate and it's placed relatively square or aligned on your sheet, using the alignment pins we saw in the when we did the test cutting, you could determine where the lower left-hand corner of the material is relative to the pop-up pins. I can actually, in my CAM software, if I know that my sheet's 4x8 and my print is 1 inch by 1 inch in, I can set it up in the file when I'm setting up my cut job in VCAV or NROUT, whatever software you're using, and then simply go to the table. If I'm cutting multiple sheets of the same setup, once I set it up once, and I feel confident that my flatbed is generating a reasonably accurate print, then I can just jump right into it. Again, you're cutting up, say, like signs that would go for, you know, for sale sign, just basic squares or the coroplast. In that situation, you just want to crank those out as quickly as you can, then that should work fine. Another question, you mentioned the cold air gun. I think that is what it's called. Why are you using it? Oh, again, when I'm cutting acrylics, when I'm cutting in general, I get heat. When I'm cutting acrylics, that becomes a bigger issue because if I don't get the proper reduction in heat, I will get rewelding. So once the chips start to re-weld to the cut edge, then I'm in trouble at that point. I can't get the right finish that I'm looking for. Another aspect of that is that the cold air gun will chill the air, get the chips moving around so I can get better chip evacuation. And that ties into whether I'm using a 5Y or pressure foot to get that good dust collection, plus using the vacuum system we have. We run the iVision, again, generating good vacuum, good chip evacuation that will basically give you nice cut edge. And the cold air gun facilitates that. What is the footprint of this model? This model is a 4010. So, and it's basically all our machines are actually about 10 inches oversized. So even though it has a 4-foot table, we make it slightly oversized because sheets don't always come exactly 4 foot, 5 foot, 8 foot. So, and then it's a 10-foot table. So you have a 10-foot processing length, plus you have an additional 2 foot in the back, give you full process with the gantry. Electrical requirements are 208, 220. Again, depending if you want to go 480. It all depends on what you have in your building. So if you have different requirements than, say, a standard 3-phase 208, we can set that up. If you have single phase, we can get the machine configured to work with single phase. If you want a different wiring setup or voltage for your pump, we can do that also. So, okay, what is the dust extraction CFM requirements? For the machine, I guess, 200. Again, depends on your system. So, and the size of your chip collection hole. So the 5Y that we use had a 2.5-inch inlet. We can go to a 4-inch if you're using a bigger dust collection system like a blower, and you have to move it, heavier chips and move it further along. We also have the pressure foot, which has a smaller, again, that's also 2.5 by default. But again, different applications, different chip collection. Okay. I think we're pretty much finished for time right now. But again, please, if you have additional questions, please reach out to us. This webinar was about the Trident we will be doing, again, more application webinars in the not too distant future. Objective is to get as much information out there to people to help them run their machines and work in different applications. So thank you again for taking the time to spend with us today, and be safe and have a great day.